Hello and welcome back to Master Tech, and today's video is going to be a continuation in our Introduction to Controls and Automation tutorial series. And in today's video we're going to write some pretty specific form of PLC logic called sequences. So one of the most common ways that long complicated routines get controlled to do things in order in factories is with sequential programming. And sequences often involve interaction from the operators at specific points in the sequence. So we're going to take a look at how to create a step and then a function where you step through it in order. And then we'll also add some features to the HMI so that you can see how the HMI could interplay with the sequence. And most important thing is, because this is kind of a continuation in a tutorial series, the concepts in this video stand alone, so if you just want to see an example of sequential logic being programmed in ladder logic on a PLC, you're in the right place, keep watching. But if you want to follow along line by line and build the same sort of things as we go, make sure that you have Ignition connected to an Arduino OPC PLC. You've already set up the Modbus connections, so I have it so that the red, green, and blue buttons, as well as the user push button, are already tied to my PLC. And then I have a PLC program where I've already set the IP address, set it up with Modbus connections, and created some very basic logic, including adding my first 4 Modbus tags. So if you haven't been following along with the tutorial series, but you really want to do this piece together, all you really need to do is watch the previous video on the channel. I'll try to remember to leave a link to it below, a card to it somewhere in the top of the screen now. But I don't want a ton of comments on this video that are like, oh, you jumped right into it with no context or background. So please get yourself in the same spot as me if you would like to follow along exactly. Otherwise, let's dive into the tutorial and the concepts in this video. Okay, now I've prepared a pretty simple prompt that is going to step out a 5-step sequence, and it's basically going to tell us what we should be trying to program. Because a really important thing about controls and automation is if you just sit down to write PLC code and you have no idea what you're trying to code, it gets really hard in terms of inputs, outputs, variables, what you need to put on an HMI. So anytime in controls and automation when you go to write new PLC code, you should have a basic vision of what you are trying to accomplish. Bit of a tangent, but basically step 0 of our sequence will be considered idle, and it'll just be waiting for an operator to press the start button on the screen. Then step 1, we're going to be activated, and then I still have the hand switch connected to my PLC from the wiring examples that we did a few videos back. But instead of the hand switch, you could use the user push button on the front of the Opta like we've been doing lately. It's up to you. But in sequence step 2, we're going to wait for a timer to complete so I can show you guys the timer function block. And then in sequence step 3, we're going to click a button on the HMI until we get up to a set point. So I'm going to show you how to create a set point on the HMI screen that operators can change and interact with. And then we will use that in our sequence. And then step 4 will be sequence completed, and it'll be sitting there waiting for us to send it to idle by pressing a stop button. Let's dive right back in. Let's dive into the programming. I'll probably pull up this notepad if we forget what the next step is supposed to be. I'll try to go slow. I'll try to explain everything as I do it. Hopefully a lot of this is familiar if you've been following the series along. So let's go ahead and go to our program. Let's go to project, and then we're going to right click and we're going to add a new program in LD, ladder diagram, and we will call this ladder underscore sequence, and let's assign it to fast task and hit OK. All right, so sequence step 0 equals idle, and we're going to wait for the HMI start button to be pressed. So the first thing we need to do is we need to check with an equals block. So EQ, we need to check if sequence step is equal to 0. So we're going to need a variable that we'll call sequence underscore step. And if it does equal 0, then we just want to tie this into the output line. So this should look familiar from the first ladder tutorial that we did. Okay, now we're also not going to worry about making all of these variables right now. I'm going to write the sequence, and then I'm going to go and look at what variables I used and kind of add them all at once. If that feels a little backwards, if you're more of a person who wants to define all of your variables and then use them, or define them as you go, you know, dealer's choice. But basically we have sequence step equals 0. We're going to listen then for a push button from a tag that we'll just call HMI start. Okay, and when the HMI start button gets pressed, that'll be something that we click on the ignition screen. So then we'll go ahead and start by resetting the HMI start push button. Okay, so you're going to turn it on from the HMI screen, and then the code will turn it off. But when it turns it off, we will also add 1 to the sequence. You could add 1 to sequence step at this step, or you could say move 1 to sequence step. It doesn't really matter. Just like any form of programming, there's a few different ways that you could write it. What's nice about this rung that we've built is it's sort of good for reusability. So we can copy it, and now we can say, all right, now sequence step equals 1. And I'm not looking for HMI start anymore. Now I'm probably looking for input 8, right? So I have the hand switch. If you don't have the hand switch still hooked up from a few tutorials ago, you could put the user push button right here. But instead, I'm going to put an HMI tag in that is monitoring input 8. Actually, yeah, that's fine. And then when it's made, we'll go to step 2. And then we could do the same reset, but that doesn't make a lot of sense because this is actually going to be looking at the hand switch. Now, the hand switch has on position and off position. And I specifically want to listen for the rising edge of the hand switch. So let's say you had left this on. I don't want it to automatically blast through this step. I want it to listen for a person to intentionally turn the hand switch on. So to do that, I'm not just going to use a regular examine if closed block, this regular normal contact. I'm going to use positive edge of the contact. So this is rising edge. This is as you detect that that Boolean variable transitions to a 1, pulse. So it's basically a 1-shot on transition high. So this step is just going to listen when we're in sequence step 1 and only when we're in sequence step 1 for the hand switch to turn on, and then it'll move a 2 into sequence step. So if we're tracking our little notepad of instructions, we have step 0, we're in idle and we're waiting for the HMI start button to be pressed. And then we have step 1, we've activated the sequence and we're waiting for the hand switch to move us to step 2. Now in step 2, we're going to wait for a timer to complete. So we haven't talked about timers yet. There's a timer on delay where when the conditions that make the timer start begin, the output is false until a set point is met. Then there's a timer off delay, which is kind of the opposite, which is where when the conditions to start the timer begin, the output is immediately true, but then when the conditions that make the timer true go away, the timer will then start counting and stay true for a period of time after that. That's a lot of gobbledygook and stuff to try to explain what ought to be a simple concept, but with PLC programming, there is just a little game within the game of knowing the nuances going on here. So let's go ahead and drop a new block that we haven't seen before, but it's TON, timer on delay. And just to show you real quick, there's timer off delay. So when you make function blocks like timers that have a few parameters to them, you have to give them an instance name. So for this one, we can just call it the step 2 TON, the step 2 TON. But the reason you need to do that is because there's an output tag, an input tag, a set time, and then an elapsed time, all of these 4 parameters, and they need to be stored in a variable or instance. Okay, so for this timer, we're going to go down to PT, and you can add constants. So if you know you always want it to be 5 seconds or something like that, you can put a constant in here. I'm going to want to tie it to a variable, which I will call, just call step 2 time. That's what I'll call the variable. And that'll be my my time that is set for the timer. So that's how long I want the timer to count up for, which will be something we'll let the user set from the HMI screen we're about to build. And then we will make, on the output of this timer completing, we will make it move to sequence step 3. Okay, Now there's a few things. Oh, I have two moves here. Okay. There's a few things we're going to change now. We don't want the input of 8 anymore. We don't need that. But there is one thing about PLC timers that we haven't included yet, and that's that the default time for almost every PLC is in milliseconds. I don't want the operator, I don't want the user on the HMI entering a time in milliseconds. It's not that intuitive. It's not how people think. So I'm going to add a multiply block in here, MUL, and I'm going to drag it before the timer, if it'll let me. There we go. And I'm going to take the HMI time SP, so set point, HMI time set point. If you don't like my tag naming conventions, I don't know what to tell you. You know, that's okay. And then I'm going to multiply it by 1,000, and I'm going to store that in step 2 time, which is the name of the variable that we just defined. Okay, so what this line is doing now is saying when I get to this step, I'm going to take the set point that's on the HMI, and I'm going to multiply it by 1,000, and then we're going to use that value in the timer. So we'll enter a time in seconds on the HMI. This will convert it to milliseconds for us, and then once the timer finishes, it'll move us to step 3. Okay, and then if we remember step 3, we're going to have a counter. So we're going to have a target number of times a button has to get clicked, and we're going to keep track of how many times it's been clicked, and then once we hit our set point, we'll move to step 4. So this one's a little bit different, and it'll probably make more sense once we get to the HMI where you can see the interaction part. But I'm just choosing to sort of start in the PLC code, and then we'll move into the HMI all at once. So it's still not too bad. We're going to say now if we equal 3, and then we want to move to 4 when this step finishes. In the middle, what we're actually checking for, because we'll do most of the hard work on the HMI for this step, so what we're going to check for here is that we're greater than or equals. So GE, a new block, and we can delete the multiplication that was for the previous step. And we're going to want to check that HMI counter. So let's go ahead and make a new tag called HMI counter in here. And we want to check that the live counter gets greater than the HMI count, and we'll say set point, SP, right there, okay? And now we need to delete this block because what we want the output to be is just set the output line. Okay, so very simply, this line means when we get to step 3, wait until the HMI counter gets above the HMI count set point, and then move to step 4 after that. But one thing that we want to keep in mind is that if you were to restart the PLC or you didn't properly clear the sequence or anything like that, how do we guarantee that the HMI counter has been reset to 0 by the time we get to this step? One of the easiest ways is actually just go to the step before it and add some branching logic. Add some branching logic around your output conditions. Okay, and we're going to come down here and we're going to add a new block to just move a 0. So come over here. And here we're going to move a 0 into HMI counter. So this is just my way of saying I really don't care what's happened to that variable up until now. I haven't needed it in my sequence up until now, but I'm about to enter step 3, and I know I want that to be a 0 when I get there. So I'm going to set it equal to 0 before I get into step 3. So that's all we're doing there. And then that's really it for our sequence. So step 4 is sequence completed, press HMI stop to send to idle. That is basically exactly what we did with line 1. Since that's exactly like the first line, we have a really good thing to reference here already. And we'll just go ahead and say, okay, that was a coil. And we're going to say, all right, when I get to step 4, then I want to move to step 0 when HMI stop gets pressed, HMI stop. And if you remember from that first line, we also went ahead and we reset the output as part of that. So if we go over here, we also want to put HMI stop in a reset. That's going to say you wrote a 1 to it from the HMI. We're going to write a 0 to it from the PLC. All right, we did a lot of ladder here without looking at the HMI. We need to add a lot of variables, so let's try to do this carefully and methodically now. If we go into the resources tab and then parameters, I'm basically going to default to wanting every one of these tags in parameters because I want to give the HMI as much information as we can. So we're going to have sequence step, that's going to be an integer. We're going to have HMI start, that's going to be a Boolean. We're going to have HMI input 8, that'll be a Boolean and we'll tie it to my hand switch. We're going to have HMI, I spelled HMI wrong. We're going to have HMI time set point. Boy, I'm struggling to type today. Time set point. That'll be an integer where the operator enters something in seconds. We'll have step 2 time. That'll also be an integer. It'll just be multiplied by 1,000. And then we're going to have HMI counter. That's going to be an integer as well. And then we'll have, we could also put the elapsed time from that timer in a variable. So we could call that HMI elapsed. And we could make, that could be an integer as well. That's fine. So we can put how much time has progressed in another variable. So on the HMI, we could also show how far the timer has progressed. I just decided that was a good idea right now. Then we're also going to have the HMI count set point. So that'll be what you need to press the button up to. And then we want HMI stop. And I may have missed some things, but that's what we're going to start by making. So let's go into parameters. And we have the user push button, red, blue, and green from before. No reason to delete those. Let's just go ahead and add. And we'll add sequence step, and that can be an integer. And then we'll add HMI start. Careful on spelling. That'll be a Boolean. And then we'll add HMI I8, and that'll be a Boolean. Now we will add HMI time set point, integer. Add step 2 time, that'll be an integer. We'll add HMI counter, also an integer. We have HMI elapsed. You guessed it, that's an integer. We have HMI count set point, integer. And then we have HMI stop, and that's a Boolean. Okay. One thing that we need to do, because it's the thing that interacts with the physical world, is we need to go in here and we need to set HMI I8, here being, sorry, I should have clarified, here being the main routine that we set up in the previous video where we just mapped our lights and push button to we mapped our Modbus tags to the physical tags that actually represent them. So here we want to set HMI I8 equal to input 8, and we want to go to our programmable inputs and make sure that I8 or whatever. I have my hand switch wired up to I8 on my Arduino. So I'm just going to make a variable called I8 that physically represents the state of the hand switch. And then in main, I am mapping the HMI tag that we just made to share with Ignition, and I am mapping that to the physical hand switch. All right, so I am naively optimistic that this is going to compile. Let's just go ahead and compile and see what we missed. And it appears that it worked, so let's go ahead and try to download it. A warm restart's required, that's fine. Initialize the database with default values, that's fine. Warm reboot, it says source code okay, so if you were to throw on the little live debug mode, which is a cool feature of Ladder and most PLC IDEs, you can see the live value of all of these tags come in. And so sequence step 0 is active right now. And if I were to click the HMI start button, or just within the code by double clicking, I can set it equal to true. What you can't see is that the HMI start went true and it immediately reset itself, but what you can see is that the sequence step is now 1. So now we're waiting for HMI I8 to go true. If I set equal to a 1, that one actually won't let me force it through because it's being overwritten in the main PLC routine. But what I can do is boot up my 24-volt power supply real quick, and I can actually trigger the hand switch. And if I go in here and I watch HMI I8, if I make the hand switch, it goes true. Okay, and actually, predictably, it went straight to sequence step 4 because our time set point is equal to 0. So the timer finished immediately and went to step 3. And then our counter is equal to 0. So it went immediately to 4. It's waiting for someone to press HMI stop. So if I go ahead and I write a true to that Boolean, it'll go back to step 0. So that's kind of as fast as you can walk through it just on the PLC to make sure it's working. So we added a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 new tags. We need to go into Ignition. And first thing from the gateway, if you were following along last tutorial, we need to expand our addresses to include those new 9 tags. So before we went from 1 to 4, this is super easy. Now we just go from 1 to 13 and hit save. The status is connected, which is great. The live screen won't change, so we open up Designer, Launcher, and we open our Gateway Designer. Open the Designer. All right, so we've got our home page. I'm gonna leave the Opta up there exactly like it was from last time. I don't have a problem with that. But I'm going to add to my tags. I'm gonna add a new folder and call these sequence tags. And then I'm going to browse devices and go to my Opta, and I'm going to go to my unit ID, and I just added tags 1, 2, 3, 4. I just added tags 5 through 13, so I'm going to store those in sequence tags. Okay, so I am adding all of the new tags that we just added in the PLC to the HMI. They're all zeros. They also all came in as shorts. But if we look back at our PLC real quick, we have sequence step, HMI start. We have the exact order we actually wrote on this notepad for easy reference. We have 1, 2, 3 bools, and so we need to change those tag types to bools. Modbus holding registers always look like 16-bit signed ints to Ignition if you don't tell it otherwise. So Opta tag 5 was the sequence step. Okay. Opta tag 6 was the HMI start. And you don't actually have to call them exact, and this one was a Boolean. You don't have to call them exactly what they're called in the PLC. It's just an easier way to keep them straight. HMI input 8 was also a Boolean and was the next tag. And then HMI time set point was an integer. And the next tag was step 2 time integer. Okay. The next tag, HMI counter, and that's an integer. Okay. Step 11, the next one, HMI elapsed, and that is how much time has passed. That can be an integer. The next tag is HMI count set point, integer. Okay. And the last tag will be HMI stop, and that's a Boolean. Go to the PLC. Okay, HMI start needs to be, well, it is case sensitive, so this needs to be a capital S for HMI start. Do you want to reassign this variable and use it as parameter? Yes. Okay, so that should be a Boolean. That should work. This should also be a Boolean. And then this should also be a Boolean. That should work. All right, all the addressing should still be fine. And then I guess since we have to download anyways, we can go back to our ladder sequence really quickly, and we can add that elapsed time that I forgot to put in here. So if we go back to resources, we just called it HMI underscore elapsed. Let's go to our timer block and let's add a variable to the ET, and we called it HMI underscore elapsed. Okay. Okay. And one thing to call out here that you could kind of see, which is also kind of nice, and maybe I did this in a bad order. If you define all your variables that you're going to need for your routine before writing your program, then they're available when you go to add variables, and you can see that they exist and what data type they are. So maybe I did a little bit backwards. I'm not perfect. Let's compile and download and restart the PLC. Initialize the database again. Okay, so with all of our tags added, we can finally do the fun part. Depends who you are. I enjoy the graphical user interface, the HMI development portion of the job. Let's go ahead and add that sequence step, right? So to the visuals, and Ignition's kind of nice. You can just grab a device or a tag and drag it onto the screen. And based on what type of tag it is, it'll show you all the recommendations for it. So like an integer, by default, they have gauges, one-shot buttons, cylindrical tanks, labels, things like that. So we'll just do a label for the sequence step, and then we'll build some more cool features into it. But let's go ahead and do little checkbox buttons for start and stop. And the text, we'll say start for the start button. That seems like a good thing to say. And then we'll say stop for the stop button. So the text stop. Cool. And then we'll throw, what do we want to throw? We want to throw our set points on the screen as numerical entries. So if we click the little palette over on the right, perspective components toolbar, we'll type in numeric entry field and drag it onto the screen. And the value will be what it's asking for. It'll be asking for a tag. So let's make this one our count set point. And we'll say value, tag path, count set point, and make sure to click bidirectional so that people can write to it. Okay, so this is our count set point. So why don't we go back to perspective components and add another label that just says count set point. So count set point. And that doesn't have to be linked to anything. It's just telling us what this numeric entry field is. And then we had one other thing that people could edit willy-nilly, and that was time set point in seconds, right? And that has to go to a different tag. That one needs to go to HMI time SP. So time SP. And I know some people are going to be furious at my lack of consistency with capitalization and camel case, snake case, made up case, you pick it. Okay, but so that'll let us enter a time set point. That'll let us enter a number of times to be counted. So then the only other thing I want to add real quick is I want to add a button, perspective components button, that is going to add one to the counter. So if you remember, we get to a step where, I also want to add indication. Let's finish that counter first. Press to count up, okay? So we're gonna make a little button, and when you press it, the count goes up, and then we will show the counter right next to it in a label. So this is the HMI counter tag, and then on click, so button, right click, configure events, we're going to do a little script here, a little ignition script to add one to the value when the button is pressed. So we go to mouse events in configuration events, on click, press the plus button, and we're going to do a quick little script that is going to be val equal to, so the current value of the counter is equal to system.tag.read blocking, and that's a little bit of just Ignition syntax for you. The tag path is going to be that counter variable. So we're going to say read the value that the counter currently has, and then little Python syntax fun that we get to play here is if we actually want the value, we say square brackets 0 dot value. So this is how you get the actual value that is in the counter tag already. And then what we're going to say is value equals val plus 1. Okay, so we're just saying, you could just say val again is equal to val plus 1. But now we're going to do system.tag.write blocking. And in that same tag path, we're going to write value. So we're just adding 1 to the value of the counter when that button gets pressed. And what's cool is it'll let you click the button at any time, but what you'll see is when we get to step 3, which is where it's actually checking it, you'll see it get reset to 0 because we only care about it when we get there. So you're starting to see how the HMI and the PLC work together to create a system that the operator has some control over, but the PLC can also be programmed intelligently to protect it. So this is how we just make a button in Ignition to increment a value. And let's see, what am I missing? When we're in step 0, we're idle. We press start. We should go to step 1. Yeah, we want to monitor input 8. And actually, to do that, I'll grab one of these buttons that we made in the previous step. This was the blue button. And I'll just drag it up here. This is input 8 up here because that's kind of physically where it is on the Arduino. And we'll have it, when it's true, we'll have it go pink. I don't care. Pick a color. All right, so then all I have to do is copy the path for that tag, and I have to say, hey, here's the tag that you're animating off of. Again, I'm assuming you watched the previous video and you know that we set this tag parameter to tie into that color animation. Okay, so real quick, we can check that color animation because I have the hand switch right here with me, and we can see whether the hand switch is on or off. Okay, very cool. So obviously it looks like crap because we haven't formatted it. We haven't made it stylistically pleasant. We don't animate things whenever. But let's go into read-write mode real quick for the gateway. So that's what these two little arrows are. And right here in the designer, we can toggle into preview mode. So now we can interact with the things. Let's say when we get to the countdown step, we want 5-second countdown. And when we get to the count up step, we want to have to click the button 3 times. Okay, I'm going to enter those. You can see right here, I can start counting up just by clicking it, and the counter is at 8. What's cool is when we get to the count up step, that should go back to 0, and we should have to start over again. One thing we didn't add, but I want to put here, is the elapsed time, and I'm going to put it in a label. But where did it go? Oh, there it is. But you guys are going to see something cool. Let me go up here. You guys are going to see that this value is going to come in milliseconds. So I'm going to let it do that this first test through, and then I'm going to show you how you can scale it in the HMI. You could scale it in the PLC. You can scale it in the HMI. Just kind of pick something and try to be consistent on your project. So we're in step 0. I hit the start button. Now we're in step 1. And we're waiting for HMI, we're waiting for input 8. So I'm going to turn the hand switch. And now we're in step 2, and you can see the counter counting up, and when it hits 5,000, we go to step 3, okay? Pretty cool. And now it's waiting for us to count up to 3. So you see this was 8, now it's just waiting at 0. So we click once, twice, a third time. Now we're in step 4, and we press stop, and it goes back to 0. Okay, so the sequence step is working, and that's really cool. What's not great is it doesn't tell you anything useful. So what we're going to do is we're going to add a transform, and we're going to map it. Okay, so this is very common when you have a numerical value that tells you something that you would prefer to explain with text. A common way to refer to this is enumeration. Enumeration just refers to taking a integer value or a numerical value and it telling you more than just a number. It's telling you a string of text, but it's easier for PLCs to pass a simple integer back and forth than long strings. So in 0, we're in idle, waiting to press start button on HMI. That's the text that we want to display in step 0. Oh, there we go. In step 1, we're active waiting to see input 8 transition high. In step 2, we're active, waiting for timer to complete based on time set point. Step 3, we're active and we want to wait for pushes to reach push count up set point. You can call it whatever you want if you don't like my step names. And then step 4, we can say complete. Press stop button on HMI to idle sequence. And what's nice about Ignition too is they have a feature called fallback, which is, I don't know how I got here. And we can just basically say sequence step somehow out of normal boundaries. And that's just basically saying you should not have been able to get here. Here's an error message telling you that something bad is happening. That can come in handy a lot. So we're going to make that label a lot wider because that text is a lot longer. And then other than that, I think the only other thing I want to do right off the bat is I want to take this thing on the screen and I want to make it in seconds. So what we're going to do is we're actually going to make this scale mode linear, and I'm going to say, okay, well, it's showing me milliseconds, but I want seconds. So if the raw high is 1000, that means the scaled high is 1. And as long as you don't do clamp mode, then it will automatically say, okay, even if I'm more than 0 or more than 1, that's okay. And then we'll make the value a float. Since now we're dividing it by 1000, we'd like to see decimal precision. Okay, so this should be a little bit better now when we test through it because it's giving us instructions. And we'll actually open the web page now. And we'll actually open the web page now and we'll run it from here. So I'm going to go ahead and hit start. I'm waiting to see input 8 transition high. And you can see it's already high, but we put in that positive transition bit. So it needs to see it high again. And here you can see fractional seconds counting up, which is nice because we set the set point in seconds. Now we need to count up to 3, 2, 3. And now we need to press stop on the HMI. Okay, we can pretty easily say, let's make the count set point 11. Let's make this time set point 7. And let's do it again. Let's press start here. Let's flip the hand switch. We're going to get to 7 seconds. We're going to count up to 11 clicks. And now we've finished the sequence. We can hit stop. And we're back to idle. Overall, this was a challenging tutorial to put together because where to start, how to make it useful, how to explain the concepts but not get bogged down in the details was all a little bit daunting. I do hope you found it useful. I think we're getting to the point where all of the basics have been covered, and I think we want to build one complete automation and controls project together. So I am looking forward to doing that. I am already sort of fleshing out what that's going to look like and entail. So as always, be sure to ask any questions that you may have in the description below. Thank you so much for watching. Let me know what you want to see next time on the channel, and keep an eye out for more controls and automation tutorials. Thanks. We'll see you next time. Bye.